Okay, let's look at these ones. So we're down here. It says express each in logarithmic form. Does it make you solve them or anything? No. We're just moving it to a log, so we're just practicing. So if I'm going to convert it to a log, I need a marker. At least it's moving now. This is winning. So we have log base what? Base 6, because the base of my exponent becomes the base of my log. Now what's going to go beside it at the exact same height as log? 216, because what's with it doesn't stay with it when you convert. And then it equals what's left over, which is the 3. Okay, cool. This one, we have log base what? What's the base of my exponent? 3, so that's the base of my log. What goes beside it now? 81, because with friends can't stay friends. And it equals 4. Okay, this one, we have log base what? 2. And what goes beside it? 1/16. And it equals -4. And then this one is all in brackets, so that's a really big base. What's my base? 2x plus 4. And what goes beside it? A. Do you see how these are the same height, the log and the a? And then it equals -1. Flip over. What's on the back side? Converting which way? Log to exponent. Go. Luke thinks Mrs. Lepp is subpar and not important.
I don't.
Okay. You're not sorry. All right. Sorry, not sorry. That's what you are. Okay. So if x is 8, we would put it in the x spot, correct? Now what your calculator is doing every single time you're actually typing in a log, which I haven't taught you how to do yet, make sure your phones are all away, because this is big and important. And when you have your phone out and you're on it, it says, Mrs. Lepp, you are not as important as my phone. If you didn't know that, that's the memo that I'm catching. And I believe I'm quite important. You know? Like I think I am. All right. Sad now. So, 2 to what power exponent is 8? That's what your calculator is doing. So 2 to what exponent is 8? 3. And it'll give you the answer 3. That's what a log is doing every single time it's calculating it. Now this one, I would plug a 4 in for x. 2 to what power or what exponent is 4? 2. So if I type log base 2 of 4 in my calculator, which I haven't taught you how to do yet, you would get 2. This one is 2 to what power is 2? 1. So the points on this graph right now would be 8, 3, 4, 2, 2, 1, right? 2 to what power? What exponent gets me 1? It's a 0. Exactly. Then 2 to what power gets me a half? -1. Because I could rewrite this as log base 2 of 2 to the -1, couldn't I? And 2 to what power gets me 2 to the -1? -1. 2 to what power gets me a quarter? -2. And there would be all my coordinates, right? So that's what your calculator is doing every single time you're pressing the log button, which I haven't taught you how to do. Now, if you're someone who's just feverishly pressing it into your calculator because you're an overachiever, I've taken this before. We're going to go through it without trying to do it with our calculators. Huzzah! Okay. And we're ready. I was dancing in the front. You wouldn't know because maybe we're on your phone, you know, and it's just not important.
No calculator.
Put it away, sir. I know you are. Stop it. Stop it, Sydney. Okay, do we need to type any of these into our calculator? And why is our calculator not always the best way? Because what if I give you variables? All right. So, what is the answer of this one going to be? 2, because I'm doing 3 to the power of what is 9? 2. What about this one? 2. 4 squared is 16. What about this one? 3. 5 cubed is 125. What about this one? 3 cubed is 27. So exciting. Now this one has variables in it. This one has variables in it. B to what exponent is 1? 0. What if you forget? Could you go like log base 3 of 1, log base 4 of 1, log base 5 of 1, and you always get zeros? Yes, you could try that. What about this one? B to what power gets me B? 1. I don't need no stinking calculators. I am speedy without it. Next page.
Would you look at the time?
Get out of here. Okay. Knowing that, for instance, log base 5 of 25 equals 2 is crucial. However, what if you were asked to state the value of, say, log base 5 of 20? Could we do that one? 5 to what power is 20? 5, what's our closest one to it?
Squared.
Yeah, squared would get us 25, right? And to the 1 would get us 5. Correct? So is this closer to the 2 or to the 1?
2.
The 2. So it's probably like 1.8-ish, right? You can guesstimate, but you can't actually figure it out. So we're going to go through how to do it with our calculators now, because sometimes we need them, but the other times we didn't. Sydney's just cranking out all the math right now. That's what you're doing. She's living in a good zone. You're a happy girl right now. She's like, I got this. Yeah, I feel you. I like math. We're in the same. Okay. So, everyone's paying attention, not trying to randomly type it in and getting it wrong because you don't know how to type it in? Good talk. Okay. So we have log base 4 of 1024. I'm showing the way that works for every single person in this room. This can be typed in like this. So you can go log 1024 close bracket divided by log of 4. Everyone's typing that in, even if you have fancy calculators and you know how to type it in differently. Because this method is important for us.
So just 124 after in brackets?
Yeah, log 124 in brackets divided by log 4. Because when you press the word log, a bracket opens up, right? So you have to divide it and close the bracket first. So this one is 5. Could we have done this one without our calculator if we knew 4 to the power of 5 is 1024? Yes. Okay, cool. 5 to what power is 221? Is there such a thing? No. So if you have the old calculators or the TI-84s where the exponent doesn't pop up, you will have to do this every single time. Log 221 divided by log 5. If you have the new calculators, press math, and arrow up till you see log base. So press math and arrow up till you see log base, and then you just type it in the way it looks. So if you have the new calculators, you press math, arrow up till you get to log base, just type it in the way it looks. If you have the old ones, you have to type it in like that. You don't have an option. Okay? It is still good to know the old method because sometimes they'll give it to you like this, and then they'll give you the answer like this. You need to know that you can work your way backwards. So actually, the people with the older calculators are in better boat because they always type it in this way. So, log base 5 of 221 is approximately 3.35. You do C and D. Okay, did anyone get this one? Log base 2 of 1 over 1,000? And it negative makes sense, right? Because whenever we have that 1 over something, you get the fraction.
Negative 9.9 is.
That's what he said. I heard it.
Yeah.
That's what he totally said. It's been there the whole time. Negative makes sense because whenever we have a fraction, in order to get that exponent, right, you end up getting a negative exponent. So that makes sense. And then this one, 3 times log base 5, or log base 7 of 512. What do we get here? It just came, that's 9 to what?
60.
62. Literally when I asked that, it just went, like the music turned on perfectly. Did we have to convert it all here? No. So, when do we have to convert from exponential to log? Well, let's look here. When we have an exponential in the form y equals b to the x, or y equals a b to the x, and we can't make a common base and need to solve for x.
What was that one?
This would just be, if you put it in the old way, you would go 3 log 512 divided by log 7. But I always use if you have the new calculator, don't do the old method. What is 3 over, guys? 3 is over 1. If you want to put something on the bottom, you have to put a 1, not a 3. Because it's multiplication, right? Fractions, numerator, numerator, denominator, denominator. If you guys are putting a 3 at the top and a 3 at the bottom, what's 3 divided by 3? 1, not 3. Okay. So here it says when we have an exponential in the form y equals b to the x or y equals ab to the x and we can't make a common base, you need to solve for x. So we know how we were just doing all the word problems and the only way you could solve them was y1, y2 in your calculator? Now you can actually solve them by converting it to a log. So how do I know I need to convert to a log? Can 3 and 2 be made to be the same base? No. How do I get an x to come down? Because solve means I need ultimately x equals something. Right? That's what solve means. Variable equals number. That's what I want. We agree? Every time I say solve. So I need to get this x to come down. The only way I can get that x to come down is to do what? Convert to a log. So let's try it out. So I get log base what? What is my base of my exponent? My base of my log then is 2. What goes beside my log? 3, because what's friends in exponential doesn't stay friends, right? And now it's going to equal, dag nabbit, my x. Look at that. I just have to type it in. It's as if I just learned the previous step previous to this, and I was set up for this. Crazy how these notes work. All right. Type that in. X base 2 to the 3. So this is 2 to what power gets me 3? So I know this is going to be 1 point something, right? Because 2 to the 1 gets me 2. 2 to the 2 gets me 4. Well, this is a 3. So what do you think it's going to be? 2 to, what is it going to be? Log base 2 of 3? What did you get? 1.58? Can we check solvings? Y1, Y2, right? We can check every single one of these with a calculator. Okay, what about this one? I get log base, what? 5 of, what's beside it? 4 equals x. Okay, type that one in. I should have let you try this one. That was on me. What do we get? 0.86? C, what's the difference with C? It's not just a x. So let's try this one together and then you'll do that one. So we get log base what? 2 of equals. And if I just want you to convert to a log, I'd be done, correct? But I want you to solve. So what do I now have to do? Add 3 and not make it join the 5. What does that mean? That means this doesn't join the log, right? I have to do log base 2 of 5, whatever that answer is, and add 3. So I'm going to go log base 2 of 5, and when it opens a bracket, I close it, and then I'm going to add 3. If you have the old calculators, you're going to go log 5 divided by log 2, hit enter, and then add 3. Every single person's trying it on their calculators. Yes, because it's not part of the log, right? If you have the new calculators, you're typing it in just like this looks, right? You make it look just like this if you have the new calculator. Everyone should be getting 5.32. If you have the new calculators, please type it in just like this looks. Don't go the old way. So you do log 5 divided by log 2, hit enter, then add 3. Some people will say, what mode do I need to be in? Are you pressing sine, cos, or tan? No, then the mode doesn't matter, right? Okay, you guys try D. All right. So here, we're going to get log base what? Log base 4, what's beside it? 7. And remember the 7 is the same height as the log, and the 4 is the subscript below. Do you see that? Please let everyone write that way, because that's the hardest thing is I come and I see what you guys do, and you're not writing them right. Okay? And then it equals what? 2x minus 1. So what's the first thing I'm going to have to do? Add 1. And that gets added onto the log, right? So the whole log gets done. Log base 4 of 7 plus 1 equals 2x. And then I divide the entirety of the thing by 2. So if you have the new calculators, I'm going to press alpha y equals enter, because I'm going to have it look just like this. If I have the new calculators, I'm going alpha y equals enter. And a fraction pops up, and then I type it in exactly the same way, because there's no way you can make a mistake if it looks the exact same. If you have the old ones, you have to go log 7 divided by log 4, hit enter, add 1, hit enter, divide by 2, hit enter, right? But if I have the new calculators, I'm typing it in the exact way it looks. And we should be getting 1.20. Is everyone getting that? If you're someone who's just relying on me to type it into your calculator, I will hope for you to do well on your test, but it's probably not going to happen. Because you need to know how to type it in, not me, right? Yeah.
When we're solving, does it always use the second one, doesn't it?
Nope, it's whatever it tells you to round to. I've just been picking the second. Yeah, if it doesn't say what to round to on a test, then you can pick whatever you want. On a diploma, they will always have a rounding rule. Okay, D looks like the word problems we've had, correct? It has an initial and a final, they're just out of order. Like this is how, if I looked at this in the word problem sense, it would look like this. Right? Similar to a word problem. An initial, a final, an initial, a doubling, and then an exponent. Correct? What did we always do first? Because we can't convert it the way it is right now. Divide that 5 over, not put the 5 and the 2 together. Correct? That's illegal. You cannot do that. Why can't we do that? Because it has an exponent. So we're going to divide the 5 over. And so we get 2 equals 2 to the 2x minus 1. Could I solve this one by common base, actually? Sure. Can I convert it? Yep, I'm going to convert it because we're in that section. 5. So I go log base what? 2. And what goes beside it? 2 equals 2x minus 1. I don't even need to type this one in my calculator. What is log base 2 of 2? It's 1, because 2 to what power is 2? 1, right? Or you can go log 2 divided by log 2 if you're typing in the calculators, right? So this is just a big old 1. So I'm going to get 1 equals 2x minus 1. And then what am I going to do? Add 1. 2 equals 2x. And then divide by 2. X equals 1. Can we check every single one of these? You can always check the solving. You could type it back in and see if left side equals right side, or you could go y1, y2 and find out where they intersect. You're doing E. Try it out. Oops. So this one, you would divide the 4 over first, always. If we have an initial and a final, we divide them. Are they always going to work out into nice like 3's and 3's? No. We just happen to do that. So we get log base 3. What goes beside it? 3, and it equals x minus 2. What is log base 3 of 3? Just a big old 1. I did this twice because this is more important that you learn that 3 of 3 is 1, or 6 of 6 is 1, or a of a is 1, right? That's why I made them the same, but they don't always come out to be the same. So we get 1 equals x minus 2, and then we add 2, and x equals 3. Now if we check this with y1, y2, we already know the answer. So we know what our x max needs to be, right? If the answer is 40, then our x max needs to be bigger than 40. If it's 3, your x max could be 10, and you'd y1, y2 it. Okay? But we did a whole bunch of y1ing, y2ing yesterday. So this is going to solve an exponential when we don't know the exponent and can't do common base, right? Okay. This one here, when do we have to convert from a log to an exponential? Well, when you need an x that's locked into the log and you don't know how to get it back out. Okay? So for example, if the log is in the base, do you know any way to get that log out? Do you know how to get that x out of the log when it's in there? No, the only way you can get it out is by converting it to exponential. So that's one. The other one is when the x is locked in beside the log. Do you want to know how to get that out? Is there any algebra that's been taught in the past that can pull an x out from beside a log? No. You don't know how to get the x out of the base, so you don't know how to get the x out of a log. So if the x is embedded in the log, the only way you can solve for x is to switch it to exponential, because that will pull that x out. Okay? Remember, you can never have a negative value beside a logarithm or in the base. So here and here, you can never have logs that are negative. You can never have negative beside a log or in the base. So when we're actually done solving for x of a log, we actually have to check to make sure it doesn't, that x value doesn't create a negative in my base or a negative beside my log. Because if it does, it's an extraneous solution. It's a solution, but it doesn't work. Okay, so with logs, we always have to check for extraneous solutions. So let's look here. Oh, the x is embedded beside the log in the base. Only way I know how to solve that is to do what? Convert it to exponential. So the base of my log becomes the base of my exponent. So what's my base? X minus 1. Cool. What's my exponent going to be then? 4, because what's with it doesn't stay, right? And it equals 3. Have we been taught in the past how to solve that? Yeah. We can either take the 4th root, or we can just raise it to the power of what? 1 over 4. So if this is 4 over 1, and I raise it to 1 over 4, I get 4 over 4. And what's 4 over 4? 1. So I just got rid of that exponent, right? So if I have a 4, I can raise it to the power of 1 over 4. Cancels. And now I have x minus 1 equals 3 to the 1 over 4. Remember when you're solving, you're doing, you have to get rid of reverse BEDMAS. That's why I could do the exponent before the bracket. Then what do I have to do next? Plus 1. So type 3 to the 1/4. If you have the old calculator, make sure you put a quarter in brackets, because your calculator only knows it's a fraction if it's in brackets. If you have the new calculators, you can make them look exactly like that, right? Alpha y equals enter. You can make it look exactly the same. Everyone's typing it in to see if you get the same answer as me. .32? Yeah.
Will it tell us like how many decimals we need to round through? Does it say anything, just 10?
It'll say which round.
Yeah.
Yeah. If it doesn't, then we can pick whatever we want. B, I want to convert it. Cool. I'm going to get 2x minus 1 to the 4 equals 6. I have a random 2 that I don't have anywhere, so I'm just going to randomly put it wherever I want, or I'm going to ignore it because it doesn't need to be there. Can I do any of those options? Yes, you have to divide the 2 over. So if you go to convert it and you have a number extra sitting out there, think, well, how could I fix it? Because remember, when you convert, you can only have 3 pieces to convert between exponentials and logs, right? 3 pieces. If you have more than 3 pieces, you have to do something first. So we're going to divide that 2 over first. And so I get log base 2x minus 1 of 6 equals 2. Oh, I forgot to check this. Guys, I forgot to check for extraneous roots. What was I thinking? If I plug this back in here, I get 2.32 minus 1, which is 1.32. Is that okay? Yeah. So it's good. And I can check them, right? y1, y2. Extraneous means if you put it in and you get if you put it into there and I sub it in and you get a negative beside the log or in the base, it's extraneous because you can't do like, if you tried to go into your calculator log base negative 2 of 7, it will fight you. It will say no solution or error or something. So this one, we get 2x minus 1 to the power of 2 equals 6. How do I get rid of a power of 2? I could square root. If I square root, what do I have to do? Plus minus. Prove a point here. So I'm going to get 2x minus 1 equals plus or minus root 6. Then what do I have to do? Plus 1 to the back, not to the root. Then I get 2x equals, I can go 1 plus or minus root 6 if I want. And then I have to divide by 2. So I'm going to get 2 solutions, correct? I'm going to get x equals 1 plus root 6 over 2. And x equals 1 minus root 6 over 2. If I ask for exact values, I'm done. Right? If I said exact values is not decimals. I would be done. But I'm going to go to 2 decimal places.
Are you not allowed to raise that one to the half?
You have to watch when you raise it to an even exponent. You're going to plus or minus, but I'm going to show you why it doesn't matter in a second, just for logs. So here we're going to get 1.72 approximately, and then this one, we're going to get negative 0.72. But when I check these, if I put the 1.72 in, I get 2 times 1.72 minus 1 is a positive number, so that's okay. If I go 2 times negative 0.72, I get negative 1.44. Minus 1 is negative 2.44. Can I have a negative in my base? No, so this one is actually my solution, and this one is extraneous. So when we did the fourth root, it's only even roots. So when we did the fourth root, instead of doing a quarter, we could do the fourth root. We have to do plus or minus. It'll kick out the extraneous one, which is the minus one. Yeah. Okay. Now what I want you guys to do is for these two, I want you to do C and D, but then I want you to actually check them by y1, y2. Okay? Let's look up here. So here, guys, we're going to divide the 2 over first whenever we have that initial and final, even if it's on a log, right? And we're going to get 2 equals log base 3 of 2x minus 1. Then we get 3 base 3 to the 2 equals 2x minus 1. This is 3 to the 2, right? This is actually easier. Why is this one easier than the previous 2? Because the x isn't actually in the base. Do you see how the x is in the base? When the x is in the base, we have to raise it to exponents or square root it and all that jazz. When the x is beside the log, 3 squared is 9. You know what I mean? So when your variable's beside the log, you don't have to square root or cube root or anything like that. When it's beside the log, you just solve it like normal algebra. So I'm going to get 9 equals 2x minus 1. And I add 1. And I get 10 equals 2x. And then x equals 5. So when the variable is beside the log, trust me, you should be way happier because it's easier to deal with when the variable is sitting beside the log than rather when the variable is in the base. So we check it back into here and see if I get a negative beside my log. So I get 2 times 5 is 10 minus 1 is 9. Thanks for answering. Is that okay? Yes? Now I told you to check it with your calculator, but I'm going to check it and verify it algebraically. So I'm going to go 4, and then on this side I'm going to go 2 log base 3 of 2 times 5 minus 1. This is done, so I'm going to let it sit there. Then here I have 2 log base 3. We said this is a 9. Then I get this equals. Then I get this equal to 2. What's log base 3 of 9? 3 to the what is 9? 2. What's 2 times 2? 4. Do I walk away from this question happy? Yeah, LS equals R. Okay, this one, I'm going to divide the 3 over. I'm happy because I see the x is beside the log, so I know it's going to be easier to solve. I get log base 2 of 3x minus 2 equals 2.
3.
Yeah, that's a 3. And then I get 2 to the power of 3 equals 3x minus 2. 2 to the power of 3 is 8. 3x minus 2. I add 2. 10 equals 3x. Divide by 3. And people get a little panicked. Because it's not just like 5. It's 10 over 3. And they worry if they're wrong. Right? So I want you all to check this. I know it's 10 over 3, which is 3.33333. I want you guys to try this in your calculator. So I'm going to type this into my y1. I don't know why that just turned to a red. Cool. And this this into my y1, and then 9 into my y2. Now, if I just type a number into one of my y2s, I have to make sure my y max is bigger than that number, right? Because y equals 9 is just a horizontal line of 9. So my y max needs to be higher than that. If it was y equals 1,000, my y max would have to be bigger than 1,000 because it's just a horizontal line. So everyone's typing it into their calculators. You should pick up your calculator. It's a crazy thing. y1, y2. We're typing it in with the 3. And then second trace 5, enter, enter, enter. And you should get 3.333333333, right? And then you can go to your screen, you can go second mode, and then you can bring up the X, and you can go math, enter, enter, and it turns to 10/3 for you. Like, it does a lot of work for you. But if it says solve algebraically and you just did y1, y2, how many marks are you getting? 0. All right. So, the extra rules to note, and I'm going to stippity star this one because these are the ones that get forgotten about. So, if I have log base a of a to the m, my answer is just m. But why is that? Because if I have log base 3 of 3 to the 7, let's say, what am I doing? I'm saying 3 to what power gets me 3 to the 7? 7. Right? Like, it's just whatever the exponent is. So whenever you go a to the m, my answer is m. The other one to note is a to what power is 1? 0. So whenever you have a base down here and beside your log is a 1, your answer will always be 0. It doesn't matter what your base is. Because you're going to say whatever that base is to the power of what gets me 1. Well, it's always a 0. And then this one is the one that I don't see often, but I'm going to show it to you anyways, just in case. So the base of your exponent, and then your exponent actually has a log in it. When these bases are the same, your answer is what's beside the log. So this is just the same. If you can't see it, it looks like this. A log base a of x. When the exponent is a log and its base is the same as the actual exponent base, your answer is just what's beside it. So knowing that, try A, B, C, D. So log base 5 of 6. What does we get? It's just 6. This one, we can say 2 to what power is 1/32? 2 to what power is 32? 5. So this is going to equal -5. We could convert it, though. We could go like this. Log base 2 of 2 to the -5, because that's what 1/32 is. And then we have 2 to the 2 to the -5, so my answer is -5. So we can do that. This one, we have the same base, and our exponent has the same base, and it's a log. So my answer is just, what is it? 25. And then this one, I say x to what power gets me 1? 0. And then this is the